again, engineering students N3, let me deal with this hydraulic section of engineering science. I hope you did enjoy other sections, so let's see how we go along with it. This section, basically when we deal with calculations, we have two types. The first one, obviously, it will be about hydraulic presses, and then the second one is about hydraulic pumps. The presses, when we talk about hydraulic presses, we are focusing on two pistons. That means we'll have a plunger and a ram. The plunger is small, the ram is big, so we'll focus around those two pistons. So everything we'll talk about will be talking about two forces or two loads. One will be on the plunger, one will be on the ram. Then we'll move on to pumps. When we talk about pumps, then basically we will have work done also under the section of pumps. Work done against a certain pressure. That means now this pump is pumping water up to a certain height. That is why you'll have pressure heads. So those heights, sometimes they are called pressure heads. And lastly, we'll do examples, a lot of them. First things first, we'll start with definitions. So let's go to definitions. What is hydraulics? It is a study of pressure and work done by fluids. That's the basic definition of fluids. And we also have what is known as hydrostatics, which is just the fluids that are at rest, and also hydrodynamics, fluids in motion. And fluids, they have to have this property, which is fluidity, which simply means it takes the form of the container or vessel because it has no form. That's what you are supposed to have when we talk about fluids. Then, since we said hydraulics is a study of pressure, now let's find out what is actually this pressure, the formula to calculate this pressure. So the formula to calculate the pressure is equal to rho. That sign is rho, it's not P. It is rho, which is the density. And the rho, or the density for water, is 1000 kg per cubic meter. Then we have G, right there, G, which is the gravitational acceleration, which is 9.8 meter per second squared. We also have our H, sometimes we refer to it as the pressure head. So obviously it is in meters. Now this formula, we usually use it when we are calculating pressures that deals with maybe the depth of the borehole or the height of the vessel that contains your fluid. Then we also have the second formula, force over area, again being the formula of pressure. But now when we deal with things that are affected by Pascal's law, that means closed systems. We have this measuring stick that is called pneumatic equivalence. So a pneumatic equivalent is the pressure exerted and expressed as a number of atmospheres. What are atmospheres? Atmospheres is just atmospheric pressure at sea level, and that is 101.3 kilopascals in value. In other words, if you have 3 atmospheres, that means we have 303.9 kilopascals of pressure. That is what is referred to as a pneumatic equivalence. So we have mass equaling rho times V. Rho being the density and V being the volume. Now I have other definitions that I want you to memorize. Please take time to memorize them. Pause the video, memorize them. I hope you did pause the video and memorized them. I'm sure now you do know the difference between absolute pressure and gauge pressure. So if you didn't memorize them, pause the video and study them, memorize them, not just to memorize them but to also understand them. I hope you did that. So now we can move to the formula sheet. I found out that in your formula sheet we have these formulas for hydraulics, which basically they are 7. 4 from this side, 3 from this side. W is for work done. Throughout, work done is equal to force times distance, or simply put is equal to, this is not rho, it's actually P times volume, because remember M is equal to rho times volume, but this is work done is equal to P times volume. This P is the pressure, that pressure, because we know that pressure is equal to force over area. So this pressure is a small letter, that is the same pressure. Now we have P, which is a capital letter. The P, which is a capital letter, is the power, and is equal to work done over time. Then we have efficiency, which is simply the output over input times 100%. Now when we come to pressure, when we deal with, remember I said that we have two types. We have presses and we have pumps. For presses, we have the force on the ram. The force on the ram will denote it by a capital letter L for load on the ram. Then we have the area of the ram. Then the area is the same like the area of a ram. It will be pi d squared over 4, and the area of the plunger, it will be pi d squared over 4. The only difference will be the d. Capital letter D will be for the ram, and then a small letter d will be for the plunger. Then we have our force on the plunger here. Usually it's just a capital letter F. So let me again give you how I denote them. We have a capital letter F here, we have a small letter d squared here, we have a capital letter D squared here, we have a capital letter L here for the ram, force on ram. Then we move to volumes. Now we have the volume of the ram equaling the volume of the plunger. Some of the times we might have N being the number of strokes if we are using pumping strokes. Then we still have the same formula, in this time written as in area and height, because area times height is the volume. So it's done on both sides because we are equating them. These formulas, all these formulas are used under presses, not under pumps. Then let's move to another slide. Then I will show you some few formulas that I have developed by myself to add on these ones so that we can have it easy. This is the formula I was referring to. If we're given the height, we'll use this formula to find pressure. But if we're talking about the pump, the pressure inside the pump, this will be the formula force over area. Then if you're talking about the pressure under the hydraulics, still the same formula, under presses. Then we have density of water being 1000 kg per meter cubed. We have mass equaling rho times V. Remember we had work done equaling P times V. So we also have these formulas. This Vp is actually the volume on the side of the plunger. So the volume on the side of the plunger will equal to the small letter diameter squared times pi over 4 times the stroke length times n times the efficiency if it is given. If it's not given, you can leave it. Even the n, if it's not given, you can leave it. it will look just like this. Now this is the area, is the volume on the side of the ram. But remember, from the previous formula sheet we saw that the volume of the plunger is equal to the volume of the ram. So in other words, we can just equate them if we need any of those. And when we equate them, we find this formula. We can just leave that one. You can just omit that one. So you can find that formula. It will also work for you. So we equated both of those formulas as we did here. But if we just wanted the RAM formula by itself, this is the one with a capital letter D squared. Then we also have the pressure. This is for pressures. Okay, let me just show you on the previous slide once more. Remember here we had L over D squared capital letter is equal to F over D squared small letter. This is it. But now we included the efficiency. Now this efficiency is the same as that one. That means it's the efficiency of the system. If it is given, you can use it. So, and you should also notice that this efficiency is multiplying your force. So if there's no efficiency, this is what we'll have. Now on the other, now we are seeing this formula which has another efficiency, but this time this efficiency is dividing the force. This second efficiency is the efficiency of the lever. That one, it was for the system, hydraulic system. Now this one is for the lever system. Okay, this is E. E is for effort, as we used in N1 and N2. This is F. This F is that one. It's not this one. This is the load. Even though it's the force on the ram, we do not use this force here. So this force is the same as that force, is the same as that force. This one. But that force could be any of these forces. Then we have the mechanical advantage equaling F over E. That means force over efficiency. F, force over effort if you don't have efficiency. So that is the formula to get when we are calculating mechanical advantage. And the final formula is the one we saw when we were equating those volumes. So this is the one. That's about it about formulas. Now let's go to our first example. Our first example is under presses. This is the hydraulic press. So let's read the question. The following information refers to a single acting hydraulic press. We have the diameter of the ram in millimeters, the force on the plunger, which is in newtons, the diameter of the plunger, obviously in millimeters, the stroke length, it is also in millimeters. They are saying if the mechanical efficiency of the hydraulic system is 80% and that of the lever system is 85%, calculate the volume of the liquid displaced after 5 pumping strokes of the plunger. Now we are given the number of strokes. That means we can be able to find the volume, because we do have the efficiency, we have the stroke length, we have the diameter. So we can have that efficiency. And since everything is given in millimeters, you can just calculate your volume in millimeters. So which formula can we use to find this volume? It depends on you. When I looked, I said this one is best suitable for this. Okay, if you are looking on this one, there is no formula that actually show all of those things, so that is why I decided to take this one. Alright, so this is the volume. We will substitute in the place of d by 12, so we have 12 squared here. We'll have number of strokes, which is 5. We'll have 200 millimeters for stroke length. We'll have 0.8 in terms of percentage. Now the term percentage means divide by 100. That means this 80 should be divided by 100. So in other words, if you want, you can just write 80 over 100 here. But if you can do it on the side, you can just write 0.8 right there in the place of the percentage. So that's how you'll get the volume of liquid that is displaced. Okay, if you did it according to the way I did it, like following the millimeter concept, you didn't change the millimeters, you just left them as they are, you'll find your volume in millimeter cube, and it will be 90,477,868 millimeter cube. That will be the volume in millimeters. Obviously, if you used meters, it will be 90,478 times 10 to the power 6 meter cubed. The answer for the volume. So let's move to the next question, which says the distance in millimeters that the ram piston will move after 5 pumping stroke. Now, have you seen that? They're saying the distance in millimeters. In other words, they really didn't want you to calculate this volume in meters. So millimeters were ideal. Now let's assume that you calculated your volume here in meters. So which formula will best be suitable for you in that case? Alright, let's come here. Actually, this is ideal because we have n, we have that, we have that. But you remember, I have simplified that formula for you on the next slide. So this is the simplified version. We can just use this formula as is. You don't have to change anything. You just take it as it is and use it right here. Right here, when they want that distance, you can just use it. Then now you'll use diameters. You'll have your 12 squared here, you'll have your 200 here, you will have 5 here, you'll have 0.8 here. Now you know why 0.8. Percent means divide by 100, so that is why it will be 0.8. 8 over 100 is 0.8. Then we'll have 55 squared here. Then you are only having one unknown, which is h, and the answer should be in millimeters. So if you didn't use millimeters, you can just plug your millimeters here and find your h. If you already use in millimeters in finding this volume, obviously this formula will be much easy for you to use, because we know that VP is equal to VR. So that means that 90,477,868 will just be in the place of VR right here. You have 55 squared there, you have pi over 4 on this side, and then you have your h. You can just make h the subject of the formula, and then that will be the answer for h. So that's about it for h. So h is equal to 38 millimeters, or if you want to be super specific, you can say 38,083 millimeters, because remember the instructions are saying that we should leave every answer to 3 decimal places. The final answer should be in those decimal places. Moving forward to the force exerted by the ram piston. Now this force is different from that one. That is the force on the plunger. That means this is F. So here we are looking for L. It's the load on the ram, so that is L. So this is the formula for it. You can just use that formula because we have the efficiency. So let's just make L the subject of the formula. There we did it. Is equal to 55 squared times 300 times 0,8. I'm sure now you know why we are saying 0,8. Then divide by 12 squared. Then we got our L. I got the L as being 5,041,667 newtons. So if you want to put it in kilonewtons, obviously it will be 5,042 kilonewtons. Now why do we have 5.042 instead of 0.41? It is because 6 is bigger than 5, so we have to round up the 1 into 2. Let's move to the next question, which says the effort that must be applied to the lever. Now they are talking about the lever, and we have the efficiency of the lever. To the lever in order to obtain a force of 300 newtons. Okay, so it's the same force on the plunger if the mechanical advantage of the lever is 10. Remember, the mechanical advantage is simple, a ratio of forces where we have the force on plunger divided by the effort. So that's the mechanical advantage. So it's just the ratio, so it will not have any unit. That's why you don't see any unit here. So which formula can we use to find effort? Obviously from N1 and N2, you knew a force to do that to be this one. But now since we have the efficiency, we will use this one because we are given the efficiency of the lever. So this is the formula that we will use to find our effort. Okay, there it is. So we have our F being 300 Newton, we have our MA being 10. 300 over 10, we have our efficiency being 0,85. I'm sure now you know why we're using 0,85, because percent means over 100. I'm sure now it's in your head. So we have our efficiency there being 0,85. So 300 divided by 10 times 0,85, the answer is 35,294 newtons, because an effort is the force, so it's in newtons. 35,294 newtons, that's what you have. And then finally they are saying the actual mechanical advantage of the system. The reason they are saying the actual mechanical advantage of the system, it is because this mechanical advantage is not felt when we have that percentage. So now what your hand actually feels is this mechanical advantage. And obviously we do have the force, which is 300 Newton. We do have the effort, which is 35,294 newtons, and we know that mechanical advantage is just the ratio of those forces. So you can divide them out and find the answer of 8,5. So that's what we have there, 8,5. I hope you did understand this example. I hope it does make sense, and if you were not writing down these answers and proving that they are coming out, obviously you are doomed, because you cannot listen to me and not see the answer and just believe everything I am saying. then if you are like that, you are doomed. You need to really work on yourself. So you need to press your calculator and make sure you are getting the same answer I'm saying I am getting. If you're not getting them, please send me a message and ask me how did I do it. I will show you how I did it. Okay, let's move to the next example. It says the ram of a hydraulic jack is 100 millimeters in diameter. So we have the diameter of the ram. The diameter and stroke of the plunger are 20 and 50 millimeters respectively. Now the term respectively means in that order. So what they are actually telling us is that this diameter of the plunger is 20 millimeters and the stroke length is 50 millimeters. That's why they said respectively, because 20 goes with diameter, 50 goes with the stroke length. Now they want us to determine the force that must be applied to the lever to lift a load of 2.3 tons if the efficiency is 85%. Obviously this is a mess, isn't it? So if it is a mess, then we need to change it into a force in newtons. How to do that? It's given in tons, so we must multiply by 1000 because 1 ton is equal to 1000 kg. So multiply by 1000 to change it from tons to kg. Now from kg you multiply it by 9,8 to change it from kg into newtons. Now we have our load on the side of the ram in newtons. Whatever value it is, you will get it in your calculator, but just follow those steps. We have the percentage, which is the efficiency being 0.85 because we said percentage means divide by 100. Okay, so they are looking for the force. Now we are not given the mechanical advantage. Since we are not given it, that will mean this force is the force that is on the plunger rather than effort or the force on the hand. So let's go on. Which formula we're gonna use? Obviously we will use, let's just look to our list of formulas. We will use this one, but we'll just include the efficiency. So this one, when it has in efficiency, it looks like this. So this is the formula we're going to use. Remember, we do have our L. We managed to find our L. So that's what you have. So that is the formula to use. We need F. We have 0.85 here. We have L being 2300 times 9.8 right here. We have 20 squared here, and we have 100 squared here. Then we make F the subject of the formula. 2300 times 9.8 times 20 squared divided by 0.85 times 100 squared. So the answer is this one. Then we are done with the first question. We've answered it successfully. Let's move to the next question. The number of strokes of the lever to lift. Okay, sorry, let me read it again. The number of strokes of the lever to lift the load 126 millimeters. So this is the same load, which is 2.3 tons, or the same one, that 2300 kg times 9.8 meter per second squared. So we are given the load. So which formula can we use for this particular task? Because we're looking for the number of strokes. Let's go and check our formula sheet. always start from the one for the exams. Number of strokes. So this is the formula we can use for number of strokes, but obviously we cannot use it in this format. We need to manipulate it nicely. Okay, so, and here it's manipulated in a nice way. We can leave that efficiency for now. We can just use that one. Okay, so let's go straight to it. So you do have 20 squared, you do have 50, we need this one, we do have 100 squared, we do have 126. So we can get our n being 63 strokes. Obviously these two on this side are multiplying, so when they cross over they will divide. Then that's how you'll get your n. Okay, let's move to the next question in line. I think it's actually the last under this section of hydraulic presses. So it says the following data refers to a single acting hydraulic press. The ratio between the diameter of the plunger piston and the diameter of the ram piston is 1:4. Okay, now the ratio between the ram diameter and the plunger diameter, in this case we can say it was 1:5, because if I divide that 100 by this 20, it will go 5 times. So obviously it's 1:5. In other words, capital letter D is equal to 5 times small letter d. That's what it means. So we will take the same concept here, we use it here. So they gave you those diameters in this format, in this time, in a format of ratios. Let's read on. The hydraulic press displacement of liquid by the plunger piston per stroke is, now that means it's a volume, 35,342,917 millimeter cubed. We are told that we should assume the stroke length of the plunger distance to be 60 millimeters and the force applied to the plunger piston to be 250 newtons. We are required to find the mass in kg that can be raised. The reason the moment you see this term raised, you should know they are referring to the ram. Anyway, the way specific here, they are saying plunger piston force is 250, so you know that you need the load on the ram. That's the first question. Then the second question, they want the diameter of the plunger. So let's face that one first. How can we solve this one with the mass of the ram? For us to be able to find the mass, if it's the mass of the ram, obviously we will reverse the process we used here. For your L, for us to find L, we said mass times G, then we got L. So in other words, now if you want the mass, we will say L divided by G, then we will get the mass in kg. I think that is clear. So we do not have L. Then how can we get L? Obviously we will come back to this formula again to get L, but this time we will just ignore the efficiency because there is no efficiency. That's the formula. We have F 250, we have small letter d squared. Okay, remember we said that capital letter D is equal to 4 times small letter d. So in the place of small letter d, we will leave small letter d as it is, In the place of capital letter D, we will say 4 times small letter d. Now, since we have a square there, we can put everything in brackets. That means you can open your brackets and have 4 small letter d all squared. Or you can just square that 4 by itself, and then you'll have 16 times small letter d squared. That's what you can have. Then d squared and d squared will cancel out. We will be left with 16. Then we make L the subject of the formula. Then the 16 will just multiply that 250, and then L will be multiplying 1 there. So L will end up being 16 times 250. And you divide that by G to find your M. This is it. That's what we end up having. Similarly, when we are looking for the diameter, we can obviously go for the volume this time. This is the volume that we have, and remember, the volume on the plunger is the same as the volume on the ram. So whichever one you want, but we are told that we must look for the one of the plunger. So this is the volume of the plunger. As you can see, the plunger piston per stroke is that one. So that's the volume per stroke. So that means we only use 1 stroke. So for 1 stroke, this is the formula. So that is the stroke length. The stroke length, which is that 60. So we will have V there, 35,342,917. Then you multiply that V by 4. Then you divide by pi. You also divide by 60, because pi and 60 will go together, 60 millimeters. And then you get your diameter in millimeters, which is there, 27,384 millimeters, since your instructions in your question paper is telling you to leave your answer in 3 decimal places. Otherwise, you could leave it as a 27 millimeters. All right, let's move to the next example. I hope you did understand. Now we are done with the side of presses. Now we are moving forward to pumps. When we deal with pumps, as you can see, hydraulic pumps, we will not have 2 forces or 2 diameters. We will only have 1 this time. Okay, let's go ahead and deal with them. The effective pressure in a single acting piston pump installation is 550 kilopascals during a delivery stroke. The piston diameter of the pump is 150 millimeters and its stroke length is 250 millimeters. So we are given stroke length, we are given the diameter, we are given the pressure. So we can get the area, we can get the volume with these 2, and we can get the pressure with those 3. So the work done with those 3. Okay, so let's read further. They are saying calculate the volume of water in millimeter cube displaced during the delivery stroke. What is the volume of water? We can get a volume from those 2. The plunger squared, the piston squared, plunger, whatever, plunger squared, diameter squared, divided by, times stroke length. Alright, let's see the normal volume. The normal formula for the volume is this one. Volume is equal to pi times, now they are saying meter cube, so that means they are telling you not to use millimeters. So in other words, we'll change those millimeters to meters. So now this will be 0.15 and this will be 0.25. So we'll have pi times 0.15 squared over 4 times 0.25. And the answer will be 4.418 times 10 to the power minus 3 meter cubed. We have found our answer, and we have satisfied our answer because it says we should find the volume in meter cube. Then the second question says the work done during the delivery stroke. Obviously we have the volume, we have the pressure. Remember from the list of formulas that the work done is equal to pressure times volume. So we can just multiply those two, the pressure and the volume. So if you multiply them, we will get our work done. That is the work done we're looking for. I hope this makes sense to you. And of course, you need to prove these answers. If you're not proving them, you are proving to me that you are not serious. You have to do your calculations as we go along. Let's move to the next example. The following data refer to a single stroke pump driven by a diesel engine which has to deliver water to a reservoir above the pump. Then we are told the pressure, the volume, 25 meter cubed per hour. So that means this is the volume in hour. Then we are given the output power of the engine. So that means it's actually the input power to the pump if it's the output to the engine. So to the power, it is an input. But you don't have to really focus on that one at the moment. Then we are asked to calculate the maximum height of the reservoir above the pump. Now obviously, if they are saying the maximum height above the pump, that means now we will use the formula for the pressure, because we said that we have two formulas for pressure. We have the pressure for open systems and that one of the closed system. So the open systems, this is the one above the pressure. So it's not in the pressure, so it's just an open system. So we'll use that pressure, and we are told that it's water. We know the density for water is 1000. We know G, so we can find this height. Okay, so let me just show you this question, this formula if you have forgotten it. Nope, it's not here. Yep, there it is. So P is equal to rho, it is 1000 times 10,8. Then that is H, this is the one we want. Then P is also given to the question. There is P. Then that will be your formula to use, and then the answer for it. Our H was 35,204. You can prove me there. Then the next question says work done by the pump per minute. Then remember what was given. We were given the volume. Okay. Before I talk about the volume, what is the formula for work done? So the formula for work done is in your formula sheet. There is the formula for work done. Is pressure times volume. So we do have pressure. We also have volume because it was given in our data. So let's deal with them. There is the pressure, there is the volume, but it's per hour. Now we're told per minute. So what we're gonna do, we'll multiply them, divide by 60 because there are 60 minutes in 1 hour. Then that will be your answer, kilojoules per minute. If you want, you can just say 143,750 joules per minute. Even that one is still fine because they told you per minute, so you should write per minute. Then we want the output power of the pump, not of the diesel engine. So it's the output power of the pump. So the formula for pump, let's just check the formula for pump just in case we don't know it. It's here. It's work done over time. So we can say pressure times, because work done is equal to pressure times volume. So we can say pressure times volume divided by time. Okay? Then let's go back there. We have pressure times volume divided by time, and the time is 1 hour. How many seconds is 1 hour? 3,600 seconds. So we'll have our 345,000 pascals times the volume which is 25. Then you divide that by an hour, which is 3,600 seconds. And the answer that I got from that was 2,396 pascals, or you can simply say, okay, 2,395,833 watts. Not pascals, I'm sorry about pascals. Then if you want to change it to kilowatts, obviously it will be 2,396 kilowatts. You can just prove me right there. Okay? Does it make sense? This is the second question under hydraulic pumps. Let's move to the third question. A single acting pump. Alright, a single action water pump with a piston diameter of 120 millimeters has to deliver 1,4 times 10 to the power minus 3 meter cubed water per stroke. The average force exerted on the piston is 2,4 kilonewtons per working stroke. That is on the piston. Now we are told, or we are asked to find the pressure of the fluid during the working stroke. That's number one. How can we find the pressure? Obviously, the formula for pressure, we do have the force. We also have the diameter, so we can get the area. So we can get our area there. So pressure will be just force over area. Area obviously is pi d squared over 4. So you can get that one. This is the force, 2,400 newtons. And then the area will be pi times. Now you have to change this one to meters. So it will be 0.12. So it will be pi times 0.12 squared divided by 4. Then you get your answer. For pressure, actually this is the answer. And then we move to the second question, which says the length of the stroke. So obviously the length of the stroke, you have the volume. The volume is equal to pi d squared over 4 times stroke length. So we have the diameter 0.12 meters squared times pi divided by 4. Then we only need SL. Then we can just find SL, make SL the subject, or stroke length the subject of the formula, and find it right there. Finally, the last question, it says the work done per stroke length if the pressure is 212,2 kilopascals. Obviously, I already told you that this was the pressure anyway. So the work done, you remember the work done is equal to pressure times volume. So you can just multiply them and find your answer for work done in joules. You can prove me right there or again. Now let's do the last example and then call it a day. Let me quickly read. The following data refers to a pump which delivers 1 working stroke per revolution and which pumps water from a borehole. The area of the pump piston is 26,274 times 10 to the power minus 4 meters squared, with a stroke length of 88.42 millimeters. They are saying the pump delivers water of 120 liters per minute. The vertical depth of the borehole that has to be pumped is 30 meters. Now we are asked to calculate the pressure at which the pump must deliver in kilopascals. That's number 1. Number 2, the volume of water delivered per stroke of the piston in liters, and finally the power of the pump in kilowatts. Now, as you can see, this example is much in resemblance of this previous example, this one. They are very similar. So I will let you prove it or do it in a similar fashion with that one. We need pressure in kilopascals. What we know that pressure is equal to force over area, and we are given the area. Do we have the force? It seems that we do not have the force. So if we don't have the force, so we can use that formula. That means we will just use the formula of rotary edge now. Because it pumps water from a borehole. So we know that it's pumping water, so that means we have rho for water, which is 1000. We still have G, which is 9.8. Then one other thing that is challenging is this volume. We are given that, we are told that this pump delivers water of 120 liters for each minute. This volume is obviously in liters. You can change it to meters if you will use it, for example here. So you might change it to meter cube now, so that it can look like that. So if a volume can be in meter cube in that way, or it can be in liters. If you want to change it to meter cube, you will divide by 1000 liters, because 1000 liters actually form 1 meter cube of a volume. So they are the same. So you can just divide by 1000, and then you have it in meter cube if there is a need to change it to meter cube. But let's just see what can we do here. We will have our pressure there. We just have the answer. So you'll analyze it the way I analyze it for you. Then you can also prove that we have the same volume. Now we need the volume of water delivered per stroke of the piston in liters, and then finally the pump, or the power of the pump in kilowatts. So this is what we have today, and I am really grateful that you took this time to learn from today's class. And I wish you all the best in your exams, because now we are approaching the exam period. Actually, some of you or some of your fellow students have started with their exams, so I wish you all guys the best of your minds. I want your minds to function to the maximum. I do not want you to depend on luck. That is why I'm not saying good luck. Rather, I'm saying I wish you all the best to be at work in your mind. So your mind should function at its maximum so that you don't depend on luck. You should pass because you worked hard, not because you are lucky. So I really applaud you when you do what I tell you to do. If you did follow with me with punching your calculator and getting the same answers or similar answers, then you are doing what you're supposed to be doing. I am proud of you if you did that. If you didn't do it, obviously by this time you are doomed. You cannot write the exams and still not be able to work with the person who's giving you information. I am here because I want the best out of you. So that is why I am dedicating some time to do these things, and I really care for you guys because it's for free. I mean, it's on YouTube, so that means it's for free. Alright, have a great time. I love you all, and may God bless you in your exam period. Thank you. Bye bye.